A 4 kilogram trash can is disgusting, so a person decides to pull on it with a force of 50 newtons. The force of kinetic friction is 30 newtons, and the trash can is said to be 10. And the trash can is slid 10 meters. Find the network and the speed of trash can after going 10 meters. Well, first I'm gonna find a network, and this is the trash can. This is the friction pulling it 30 newtons this way, and then that's it being the tension being pulled 50 newtons that way, and the full distance is taken up is 10 meters. And the trash can starts at rest, which will be important for the speed of the trash can. And this is my free body diagram. Gravity is working on it, normal force is working on it, and tension is being pulled and the friction. And this is where I have depicted as being pulled 10 meters this way. So first I find the work tension, which is 50 newtons, because it's being pulled this way 50 newtons, and it's being pulled on by a rope as stated in the problem. So the tension is 50 newtons times the 10 meters that's being pulled. And cosine 0, I derive cosine 0 because the force and the distance is being pulled forms a 0 degree angle, and they're both going in the same direction, so it's 0. So I got 500 joules for the work tension, and I have 30 newtons for the friction, for kinetic friction, times the 10 meters is being pulled to the right, the times -1, which I derived because the friction is pulling it this way to the left, but it's being pulled towards the right 10 meters, so this forms a 100 degree angle, and cosine 180 translates to -1, and that'll give me -300 joules being transferred to the trash can for the friction. The work of the gravity, well, first I had the mass 4 times the gravity to get 39.2 newtons times the 10 meters is being pulled to the right, and cosine 90. I derived cosine 90 because the gravity is pulling it down, but it's going towards the right 10 meters. So this is a 90 degree angle. Cosine 90 is 0. So with that being said, there's 0 work being done. And not only that, there's also just a known thing in work energy theorem or principle that if the distance is going in a linear direction, left or right, and a perpendicular force comes, there's no work being done on it if the force is perpendicular to the distance. So with that being said, the normal force will also be 0 because the normal force is going up in the problem, but the trash can has to go 10 meters to the right. So the net force is 500 from the tension, the 300 joules, minus the 300 joules from the friction, plus the gravity and the normal force, that gives you plus 200 joules. Now to find the speed, I know the work net now, so I go to the change of kinetic energy in order to find the speed. So since I have to know the work net, I use this work energy theorem. So I have 200 joules equals 1/2, and since this trash can start at rest, I can get rid of the initial velocity, and I plugged in the mass, which is 4 kilograms. So I have now 200 equals 1/2 times 4 kilograms, and I need to find the velocity. So 1/2 of 4 is 2. I divide 2 by both sides to get 100. 100 VF squared. I get the square root of 100 to find the final velocity. So I get that the final velocity of the trash can is 10. So the trash can was going 10 meters per second